Yeah.
Is it recording? Okay. Welcome to Swag. Geometry 101. Today we'll be talking about the derivation of the compound interest formula. Alright, so let's start it off like this. Let me explain how this formula works.
You know what a twit is?
By using 3 years.
Oh, okay.
P1, the 1, comes from the year. This is for 1 year. It's as simple as this. We're going to use an example. P is going to equal 36,000. And our rate will be 4%, which is 0.04. As you can see, when we plug our numbers in, we get 36,000 times 1 plus 0.04. This is for 1 year. For 2 years, we're gonna take this and we're gonna square it. So basically, it would end up looking like this raw. P2 equals P times 1 plus R, and then again, times 1 plus R, which is easily written as P times 1 plus R squared. So our example would end up looking like 36,000, which is our P, 1 plus our percentage, which is 0.04, squared, because we have 2 years. The same thing would happen with 3. But P3 is going to equal P times 1 plus R times 1 plus R times 1 plus R, which is easily written as P times 1 plus R cubed. So our example would look like 36,000 times 1 plus 0.04, which is our rate, cubed. It's as simple as that. Cubed. Now, if you want to get any time, just use T. So basically, T is the number of years that you want to compound. So if you want to compound 5 years, you plug in 5 for T. So your formula ends up looking like this. P times 1 plus R to the T. To the T is any number. You can plug in any number for T. So if you want to know after 100 years, 36,000 times 1 plus 0.04 to the 100.
Then the reason why we put today is so that you can factor out y. So both of them have y. So you write y, parentheses, and then write
Now when you're talking about compounding more than once in a year, you're going to use this formula. A equals P times 1 plus R over N. And this is the number of compoundings per year. This is your amount, this is your starting amount, this is 1, and this is your rate. So let's say, for instance, we compounded once a month. There's 12 months in a year, therefore N would be 12, because you're compounding once a month. There's 12 months in a year. So for an example, again, we'll use the same starting amount. 36,000 times 1 plus 0.04 over 12, because we have 12 compounds in a year. The same goes for monthly, which is this, binomial, which would be 2, quarterly, which would be 4, and weekly, which would be 52, because there's 52 weeks in a year. Now, that's the compound interest formula. Let's go on into explaining what E is for a continuous compounding formula. E is simply 1 plus 1 over x to the x as x gets really big. That is e. Now, e is taken into a whole different type of formula. If you're trying to compound over and over and over again, and not by a certain amount. So, let me explain here. This is the compound interest formula. This is for a continuous. As you can see, the formula deviates from here. So, if we get 1 plus 1 over n to the n, which is pretty much this formula. The m and the 1 end up canceling, which makes the constant e equal to 2.7182 as a value. That's the value of e. By letting the number of compound n increase without bound, it is now becoming a continuous compounding. Therefore, it's never stopping. By letting n over r equal m to the formula, which we just explained, numbers end up getting moved around to this state. Now we'll do a few examples.
Let me give you something, okay?
Yes.
We're going to do 2 examples for you.
I got your phone.
First off, we're going to do...
Ready?
Alright. We have a total of $36,000. We're going to use the same amount as before.
Okay, so where is my camera?
But this time, we're going to make our percentage 9%, which is 0.09. We want our account to be compounded every week, which is 52 weeks in the year for 4 years. Again, we're going to multiply by 52.
I saw it, right? I was like, seriously, I was like,
You guys say you need before you go. You work with
Hurry up. Okay.
I can find the curing. If you already come back today, make sure you send in.
So, let's go ahead and see what that total is.
oh, video?
Yeah, we're recording, Kathy. You might want to, like...
I'll be chewing some right now if I did.
Nah. Alright, so that's our answer. That's the amount of cash we're gonna have. That's a lot of money. Now, that was for weekly compounding. Now we're gonna give you an example with continuous compounding. So continuous compounding, we forgot our formula, which is PE to the RT, which is our constant compounding, our rate, and our years. So we're going to use the same number again, 36,000, times our constant to the 0.09, which is 9%, times 4, because we're doing 4 years. So let's go ahead and calculate that.
Don't forget your...
Oh, true.
Which again gives us our total for continuous compounding. And that's pretty much it, folks. I hope you enjoyed this episode of Swagometry 101. I'm signing off.